everyone, welcome back to the session. Myself Prashanth. Today I am going to discuss about implementation of basic gates into NAND gate in the digital design and computer organization. Design of basic logic gates using the NAND gate. How to implement the basic gates into the NAND gate we can see in this session. Today's session agenda is first introduction and truth table for the basic gates. Next, finally implementation of NOT gate to NAND gate, AND gate to NAND, and OR to NAND gate. How to do the conversion of all these basic gates into the NAND gate we can discuss. Now introduction. There are mainly three gates, that is AND, OR and NAND, and every gate has its own different logical functions. So with the help of these basic logic gates we can get logical functions or binary or boolean, else any logical expressions. First one is NOT gate, second AND, as well as finally OR gate. First one gate, basic gate, is NOT gate. This logically gates is much simple type and digital logical circuit. This gate has only two terminals, one is for input, another one is for output. Input gets a binary number, that is, it can be only 1 or 0, not other than 1 as well as 0. Then the output terminal is logic gates is always opposite to the input. If I give 0, it will be converted to 1. If I give 1, it will convert it to 0. Which means we get 1 at the input. Then the output will be 0 and vice versa. It will be going on. This is about the NOT gate. Then next come to second AND gate. AND gate consists of two input terminals as well as one output terminal. The working of these such output terminal we will get binary 1 and only if the input are binary 1. In the case of any of the input has binary 0, then the output will be 0 only. The number of phase possible is equal to 2 of n is equal to nothing but 2 of 2. 2 square is equal to 4. Truth table for the AND gate is, if I give here input is 2 but output will get only 1, nothing but 0 and 0, nothing but it is multiplication. The sign dot sign indicates the multiplication. Then 0 into 0 is nothing but 0. 0 into 1 also 0. 1 into 0 also 0. Then 1 into 1 nothing but 1. If we give the 4 output, it will give the 4 inputs. Next, last one basic gate is OR gate. Likewise, and OR is also one of the fundamental logic gate which has two input terminals and one output terminals. Nothing but 0, 0. That AND gate is the same, indicates multiplication symbol, but its OR gate indicates the plus symbol. If 0 and 0 is equal to 0, plus 0 plus 1, we will give the answer 1. Then if I am giving 1 plus 0, nothing but 1 only, then 1 plus 1 also it will give 1. This is the truth table for the OR gate. It is same like a AND gate, but the sign will be different in this case. Next comes to the main agenda of this session, transformation of NAND gate into the other basic gates. First one, construction of NOT gate with the NAND gate. We have need to only input terminals, so both input terminals and NAND gate is being sorted by us, which you can also find out in the figure above. Now, when we give binary 1 at the input terminal, we will got the 0 at the output due to the property of the NAND gate, which is seen from the truth table of the NAND gate. You can see here, this is the simple AND gate. If we will give the one bubble like this will convert it into the AND gate. This is the conversion of NOT gate to the AND gate. If this bubble is not there, it will be treated as NOT gate. If the bubble is, we will put one bubble, it will convert it into the NOT gate. This is the conversion of NOT gate to the AND gate. Now second one is construction of AND gate with the NAND gate. First, I am giving here input A and B, that is 192. The output will be 3, nothing but A into B. But here bubble is there now, that is nothing but AB complement. nothing. Then 4 and 5 I will give. The output will be 6. That is A and B. A into B. The complement, whole complement is converted into the complement, and whole complement it will be negligible. Then it will act as A into B. This is the conversion of the AND gate to the NAND gate. Finally, construction of OR gate with the NAND gate. How to construct the OR gate with NAND gate? Nothing but one should be familiar with the D.B. Morgan's theorem. Before getting familiar with this one of it says complement of the product is equal to the sum of the component complements. Nothing but here I am giving A as 1 and 2. Nothing, output will be 3, nothing but A complement. Then B 4 and 5 will be output will be 6, B complement. A and B whole complement are in this. When it will go to the NAND gate, it will convert it into A plus B. This is the specialization, or this is the characteristics of the NAND gate. This is the conversion of the OR gate with the NAND gate. I think all are familiar with all these things. Today we will discuss about the introduction and how, what are the basic gates and how to convert that, how to implement that basic gates into the NAND gate. Okay, thank you for watching. Please like, share and support.